My name is Gumirov, yes. I'm Russian, so it might be a little bit tricky. Not so tricky as my colleagues from Poland or Slovakia or Czech, where it can be even more sophisticated. So I will talk about challenges I see from our practice in PANNet when we deal with onboarding of different vendor solutions. We have quite a huge lab data center where we do more than 20 POCs simultaneously with different types of VNFs and software and so on. We did quite extensive learnings on this journey. Initially, I wanted to call this presentation like the good, the bad, the ugly, but I decided not to be too pessimistic. Yeah, Russians have to be optimistic, but because I live in Germany for quite a long, I learned a little bit of German careful engineering culture. Look for troubles and predict them, yeah. So, let's move on. Colors are fine here. So there should be a road here. This is the path from what we have, the black box, to the brilliant future of cloud-native VNFs. How we define cloud-native, it will be the next slide, but honestly saying, all industry started with most applications like simple virtualization of the software, then some kind of decomposition, cloud readiness, then cloud friendly, and what we want to achieve is some kind of architecture where application can be deployed on multiple clouds. It should be cloud agnostic, it should be technology agnostic, it should be pure user experience and pure code. This is what we want. This is definitions of cloud readiness of applications we found out maybe a couple of years ago as a guideline for us. I don't want to focus on them much. I want just to focus on the fact that with every step where you go deeper in the cloud, your application becomes more and more, I would say, abstracted from a particular lower levels. It uses more platform capabilities, relies more on the native cloud features. And clouds are more mature today. They have containers, they have functions as service, they have serverless things, storages, whatever things. And you rely mostly on them and you concentrate on application development. It's true that VNFs are not the same. So my critics will be more moving into the high performance VNFs. Because we know that telco landscape is quite broad and we have plenty of functions which live on the high level of OSI model. And they were very fast and first to be, first of all, cloudified in terms of cloud friendliness, and maybe they are somewhere cloud resilient and close to cloud natives. In our experience, voice application platforms like TAS, telephone application servers, a lot of them are maybe somewhere in between these stages, and some platforms which provide value-added services or some OSS functions. But as soon as we come to the mission critical, I would say performance critical functions, the ones which are dealing with traffic itself, trend is a little bit not only slowly but scary. Yeah? So from my perspective, it's a little bit of a contradiction. So where we are, it's a bunch of smiles, but not of them are happy smiles. So we have high performance, and we evaluated it quite well. So we went through DPDK evaluation, we went through SRIOV, we're dealing with SmartNICs. My colleague and boss Stefan Schnitter in the previous sessions was talking that we're getting there. This is, I think, known, so that's like, we know how to solve it. Why we were focused there, it's quite clear. Traffic is growing, we have higher demands, and operators have to keep cash flow, so we cannot have a revolution. It's obvious. When we come to other things like automated application management, horizontally scalability, these are the pain points which have started to pop up. With all the claims, and I admit that vendors trying to fix these things, there are things they cannot fix, and there's for horizontal scalability, especially for large performance VMs, we don't see it. And tricky thing is, in lab you can have some demo, and when it comes to live deployment kind of consultation, producers of VNF say, better precise, like oversized VMs not to do the horizontal scaling. So a lot of deployments in the race of high performance, they try not to leverage cloud platform capabilities. So let's do everything inside, in the VNF. Let's do redundancy in the VNF. Let's do connectivity in the VNF. Let's do routing, everything in the VNF. So there is kind of quite understandable race for that, because DPDK stack and separation of multiple components of complex solution is not really so effective. It creates a lot of delays and worse user experience. So fault tolerant and resilient design somehow exists, but it's not as cloud native and cloud perfect as for applications that we tend to see as our goal, especially applications like, I don't know, web-based applications like WhatsApp and some voice services and so on. And they're definitely not microservice-based. So from my perspective, we have a very interesting trends. So in the last years, we can clearly see that in the cloud industry, the ones which we are looking at and the industry from which we take our practices, our production practices, CI/CD pipelines, automation, everything, this is trend to get to more abstracted application design, to get more cloud agnostic, runtime agnostic, function as a service, horizontally scalable. So that means application is deployed everywhere. But in some especially critical, performance critical applications design, in our cases, we saw opposite trend. So applications become larger, they're consolidating more functions in the same VM to gain traffic processing efficiency. They become more hardware dependent because this race for performance leads us to stick to SRAV, to particular hardware vendor, to selection of particular even CPU models, and discussion with any vendor who will offer you high performance virtual PC or BNG will be like that. If you select this type of server with this CPU, with this NICs, with this amount of RAM, with this type of hard drive, we give you the number which we tested and we guarantee. If you deviate from it, it's your risk. So that means in reality, it's quite clear that hardware dependency is somehow invoked in this process, and it leads to that. Which steps? So I created some kind of logical mapping, because as an engineer I tried to understand how did we get there. So from initial view of everything decomposited, distributed and abstracted, in a few years we ended up into kind of bulked, huge monolithic concept of few VMs running on high performance compute nodes. It's quite clear. First starts from demand. And this is why I'm not trying to blame vendors. It's a guild of operators who maybe did not estimate fully the complexity of this task, and they gave huge pressure in the industry to go into the cloud but continue to give us high performance results right on the spot. So, and it's quite clear we need to keep cash flow. There was some talk, unfortunately I arrived yesterday so I missed initial talks, but I heard somebody said we need revolution. But it's a little bit of, I would say, risky message what I see, because operators can claim about revolution, but if you talk to their management and financial management, they don't want revolution. They want income to grow and they want profits to grow. It's quite clear. Technologies are not mature, so I don't want to go in much details, but I would say DPDK is the only choice for acceleration, but it's far from perfect, and it has to be improved. Smart NICs are somehow helping us, but they are not helping us to offload immense amount of work. Smart NIC will not replace your hardware router. It's a lot of trade-offs here. And standards. This is another input. Actually, old standards were built in the way that they are not in kind of, this is really funny. When I started to learn my communication, after my studentship, I studied mathematics originally. First thing you start is OSI model and TCP IP model. You read about layers and abstractions. And when I look at some of the standards, 4G, 3G, whatever, I see that it's kind of forgotten. We are merging too much in the standards themselves, and this way of merging leads to this monolithic design. And when we try to bring this compatibility, backward compatibility into the cloud, we tend to kind of do the same design and software in the cloud. It's a tricky point because we need somehow to break it, and I hope that in the future with new standards we will be able to break it. So and then we come to the conclusion. So this is intermediate step. We have bigger nodes, more monolithic code, more hardware dependency. VMs become too big to fail. And this too big to fail has a very big psychological factor, because human factor is big, and we all rely on the past, and we have this fear of fail, and we know the bigger component is the severe damages. So that means we have virtual deployments. We have maybe virtual APC, BNG deployments, but they are so big to fail that the life cycle practices that we invoke in them and we start to do, they are not really cloud friendly. It's like legacy practices in the cloud. Maintenance hours, be careful, manual user transition, because technology is not allowing a lot of it. Some cases, I put some things about virtual APC. This is maybe the most pain point for us now, because we have some pressure to scale it up and to run. But one of the things, for example, it's very interesting. East-west traffic. A lot of architectures invoke a lot of this horizontal traffic within the data center between elements. One can say, yeah, but web applications also have east-west traffic, and quite significant one. But the problem with our way is that we are trying to implement this hardware bus, and what we do is we are not generating value added, so any added value with this traffic. In web platform, when user request comes into the front end, backend traffic is not just retranslation of user information. It's creation of response, it's additional metrics, it's targeted advertisement, it's a lot of things on the background, user experience, measuring, whatever, just to produce more services for user and to capitalize on them. In our case, a lot of this east-west backplane traffic in data centers, which cost us a lot of resources. It cost us data center networking, it cost us server NICs, high-performance nodes. It's nothing, just the same user traffic just shifted around. So we bring no value in it. It's a very ridiculous situation. Then part of the limitation we found in the current mobile network is that scaling in and scale out theoretically can exist, but in reality nobody wants to do them. Because user processing is so tightly coupled with the networking, and while network is mobile, and this is really curious learning for me, was that network is claimed to be mobile, but it's only mobile in RAN. In the core, it's static and it's anchored. User is hit with nail to the particular processing unit, and that's it. And then this identification of the user is not in the application and abstracted level. It's in the network. We have to hit this network unit all the time. It's a very strange thing. So that means the worst situation for scale out is that even if you have to scale out because your CPU resource is overloaded and you spin off new VM, you cannot move active users from the machine which is overheated, because active user movement means tear down active session. Calls are dropped, data is dropped. And this is experience nobody wants to invoke, because it means worse quality of experience for user. This is the challenge, and this is not the guilt of vendor or whatever. It's the standard that we have. And because moving forward, standards are built like that in legacy. We have responsibility domains, we have users, we have some access, we have aggregation, and we treat each domain as a separate zone. And we treat them only from communication perspective, trying to make perimeter working. We completely ignore this transparency way, that's why web application works, because they look from application perspective in the beginning, and they try to address this layer in the seamless way as much as possible, and to push abstractions as much as possible there to be less dependent on these layers. This makes this evolution so fast and so nice, because, I mean, for all of us who work in the telecom industry, you know how painful it is to migrate to IPv6 from IPv4. And it's a very funny story, because how complicated it can be. But it is complicated due to the fact that applications are abstracted and you cannot capitalize on that. It costs you money to change your network, but for user, it doesn't matter what transport it has below. It just works. That means why should I pay for a thing which is transparent for me? And the same, unfortunately, should be in our standards for communication, but it's not yet there. So I really think that we have this cross-dependency. So I don't want to have this, how to say, very pessimistic message at the end of my speech that everything is ruined is bad. But I think all telecom standards and discussions in the future have to now have into account this kind of end-to-end picture. And unfortunately, maybe we have to go back to basics. We have to relearn again OSI model, understand its values, understand the value of abstraction, and try to decouple network from application as much as possible. So that's, and then our cloud applications will become more web-like, more distributed, more microservice, and more scalable. That's it. So it's end of my speech. It's a little bit pessimistic and provocative, but I hope it gives us a lot of work ahead. If you have any questions, I have 4 minutes now. So. No? Okay. I hope I did a good job then. Or you are not bored. Thank you.